So what's the first step that I want to do here? Marina?
Add 64.
Okay, that gives me this. Now what?
Find the square root.
I want to take the square root of both sides. When I take the square root of the left side, in other words, I want to do this. The left side is x, but the right side is plus or minus 8. Always remember that whenever you're solving an equation by taking the square root of a number, the answer is always plus or minus. Okay? Now, number 2, what's the first step?
Subtract 18.
Okay. What's the next step?
Well, it's no solution because it's a negative, but you would find the square root.
Right. I would try to take the square root of both sides, but the moment I try to take the square root of that, you can't take the square root of a negative number.
Yeah. So
there's no solution for that. Let's go down one here. X squared minus 11 equals minus 11. First step?
Plus 11.
Right. In other words, the first step is to try to isolate this as best we can. And we do that by adding 11 to both sides. Now we have this. What's the next step?
Find the square root.
Square root of both sides. Square root of 0 is 0.
X equals 0, yeah.
And that's the only one you don't have to put the plus or minus in front of.
Because 0 is 0.
In other words, plus 0 is the same as minus 0, so we don't have to say plus or minus. Okay, how about this one here? First step? Marina?
Plus 75.
Okay. Second step?
Divided by 3.
And third step?
The square root.
So x equals what?
X equals 5.
Plus or minus 5. That's how you get both of those answers there.
Okay, hold on.
Okay.
The house phone's ringing.
Okay.
I'll be right back.
Sure.
Okay, I'm back.
Okay. So number 5, what's the first step?
Minus 12.
Second step?
Divided by 2.
And third step?
The square root, but you can't find the square root of a fraction, so it's a no solution.
So whenever that other side is negative and we have to take the square root of it, we got problems. Okay. First step.
Subtract 4.
Second step.
Divided by -6.
Third step.
The square root. So x equals 0.
Huh? Okay, solve the equation using square roots. Use a graphing calculator to check your solution. Okay.
I don't have a graphing calculator, so I don't have to do that, but...
Okay. Now, notice here that we still want to isolate x, but what's the first step here?
Like for number 7, right?
What's that?
For number 7, right?
No, let's go through the steps because these steps are very important. What's the first step?
Number 7.
First step would be to take the square root of both sides.
Yeah, but are we doing the problem number 7?
Oh, I'm sorry. When you said 7, I thought you were answering the question. Yes, we're doing number 7. I'm sorry. My fault.
It's okay, thanks.
So the first step is to take the square root of both sides, which leaves x minus 4 over here. What do we have on the right now?
7.
Plus or minus?
Plus or minus 7.
Okay. So now what's the second step?
Add 4.
Okay, so now we got x equal plus or minus 7 plus 4. So what are those two answers?
X equals 11 and x equals -3.
Okay, you see how you get the -3? In other words, when I add 4 to that, I get -3. When I add 4 to the plus, I get 11. Oh. And gradually they get a little harder. Notice that our steps are not always in the same order. What's the first step here?
Divide by 16.
Yes, leaving behind. In other words, our goal is always to try to isolate x. So we whittle it down. What is this? 36 divided by 16, which is the same as 9 divided by 4. Okay. So now we've got x plus 3 quantity squared equals 9 divided by 4. Now what's the next step?
No, I'm on the thing with him right now. Sorry, I'm talking to my mom on the phone.
It's okay.
Yeah, we're still connected. Okay, bye. Love you. Bye. Okay. Sorry.
Okay. It's all right.
She said that you sent her a second code.
What's that?
She said that you sent her a second code.
Still didn't quite understand what you just said.
She said that you sent her another code, so she was wondering if I was still...
A meeting ID number. No, I just sent her one. I sent one to that main phone that I have. Yeah, I only sent one. And you got it, right? You must have. You logged on.
Yeah.
Uh-huh. Huh.
Huh.
I didn't send her a different one.
That's weird.
She may have gotten the same text message that your home phone gets or something. I don't know. Is that phone that I send it to, is that your home phone, or is that your cell phone, or is that her cell phone? Or?
That's her cell phone.
Okay. That's where I sent it. Maybe she forwarded it to you, and that's how you got it. I don't know. But everything's copacetic here. So we're down to x plus 3 quantity squared equals 9/4. What's the next step?
The square root.
Okay, so the left, now what, help me write it. So the left becomes this.
3.
Well, let's do it one step at a time. What's the right side when I take the square root?
3/2.
Okay, that's almost correct.
Negative 3/2.
Plus or minus. Remember, it's always plus or minus. So now, what are the answers?
Well, don't you have to subtract 3?
Correct. So x is plus or minus 3/2 minus 3. So what are those two answers?
Negative 3/2 and 9/2.
And negative 9/2. Okay. However, I mean, you knew that because it was on there, but you see how we get there?
Yeah.
In other words, the negative 3/2 comes from taking a positive 3/2 and subtracting 3. And the negative 9/2 comes from taking a negative 3/2 and subtracting 3. All right. Number 9. So what is the formula? Hold on a second. What is the formula for the volume of a rectangular shed? What's the general formula? For volume of a rectangular solid. You always want to start these problems out by writing the general formula. That's the secret, I think. So what's the volume of a rectangular brick?
Length times width times height.
Uh-huh. Okay, so that's the general formula, and what they're giving us here are the height, the length, and the volume. In other words, they're giving us 3 out of the 4 variables, which means we can solve for the missing one, which in this case is the width. So let's plug in what they give us for volume, 972. The length is 1.5. The width is what we're trying to solve for. I guess I could write that as x.
Isn't it 1.5x?
Ah, yes it is. Thank you. I didn't see that x there. And the height is 8. Now the fact that that length was 1.5x instead of just 1.5 doesn't really matter because it still leaves me with one equation and one unknown. So what's the next step here? 972 equals what? 1.5 times 8 is 12. And what's the rest of it?
Oh, 12x
Squared.
squared.
Yeah, because you have an x times an x. That makes x squared.
Now do we find the square root of both, or divide by 12?
Not yet. You gotta get x as isolated as you can do it. And
So
since
divide by 12?
since the 2 is not acting on that 12, it's only acting on the x, then I got to divide that 12 first. In other words, this is not the same as if I had written it like this. If I had written it like that, I would take the square root of both sides next. But since there's no parentheses around the 12, that means that that 2 is not acting on the 12, it's only acting on the x. So I can further isolate the x by dividing both sides by 12. Do you have your calculator handy? What's 972 divided by 12?
81.
Okay, so now we got 81 equal x squared. What's x equal to?
9.
Well, plus or minus 9.
Plus or minus 9.
However, because we're dealing with dimensions of a real building here, we throw out the minus, and it's only plus, because dimensions cannot be negative. There's no way you can have a dimension of minus 9 feet. So even though the equation gave us a plus or minus 9, in this case we're going to only keep the plus because of the nature of the problem. If this was just an equation and wasn't concerning the dimensions of this building, then the x would equal plus or minus 9 would be the answer. But because it's a building, we know better. Okay, is that the last one on this page? It looks like it. Okay. Okay, I presume that you've been taught two different methods of solving two equations with two unknowns. One of them is substitution, and the other probably is elimination. Yeah, I see that 5 and 6 are elimination. All right, let's do substitution first. Number 1. Substitution is exactly what it says. I'm going to substitute one variable for another, and in this case, y, both equations are written in terms of y equals. So how do I use substitution to solve this?
I was gone when we learned substitution and elimination.
Okay.
I don't know how to do this.
Okay. Well, there's two things you can do here, even if we solve it by substitution. The most obvious is that I can take the simpler equation, since both of them are equal to y, then they're both equal to each other. So the next thing I can write is this is equal to this. And now we solve this quadratic in the same way we would solve any quadratic. Let's do it just for practice. What's the first step? Remember, when we're looking at a quadratic, we want to end up with 0 on one side and everything else on the other. That's unique about a quadratic. So what?
Subtract 3x minus 1.
Okay, I can do it one at a time. First, I'm going to subtract 3x from both sides, and then I'm going to add 1 to both sides. So I'll do it in one step. Okay, now what? Now it becomes what kind of a problem? Okay? Factor this for me.
It would be
Let's do it step by
x
step. Okay, good. We got that far. Now what? We're looking for factors of 3 that do what?
Add to 2.
Subtract to 2. And I don't mean subtract to plus 2. I mean they need to subtract to this coefficient regardless of its sign. Well,
1 and 3.
1 and 3. Those are the only 2 factors of 3. And then we're going to put the largest of those factors with the sign of the middle term. So the 3 part's going to go here, the 1 part's going to go there. So what are my 2 solutions now?
X plus 3 equals 0 and x minus 1 equals 0.
Okay, that's correct. So x equals
So
what?
Negative 3 and positive 1.
Right. Okay, good. Two is essentially the same thing. So what's the first thing I'm going to do? Since y equals that and y equals this, what am I going to do as my first step?
Put 4x plus 2 equals x squared plus 6.
Next step. Let's do it one at a time. Let's do the x variable first.
The 4x or the x squared?
No, we've got the x squared on the left side of the equation, which is where we want it. But we need to move both of these to the other side of the equation. So let's move the 4x first. So that becomes x squared minus 4x plus 6 equals 2. And now we'll move the 2. X squared minus 4x plus 4 equals 0. Okay. Help me.
It's minus plus.
No. We're going to
Or
examine.
minus.
This plus sign tells you that they both have to be the same. They either have to be plus plus or minus minus. And then minus minus because of the middle term. If the middle term is minus, then there has to be minus minus. And now, because this was a plus sign, I want factors of 4 that add to the number 4. So what is that? Factors of 4 that add to the number 4. Not my 2 and 2. And notice that I didn't say minus 4. I merely want factors of 4 that add, because of that, to this number right there. And that's 2 and 2. In other words, I already have my minus sign on there. So if x minus 2 times x minus 2 is equal to 0, what's my solution?
X equals 2. X equals 2.
And only 2. Yes, not plus or minus 2. Okay. And okay, 3 is a little different. Notice that the second equation in 3, I don't have a y equals anymore. I got y minus 1 equals. So I might have to do something first before I use the same technique that we just used. What would that be?
Subtract y.
Well, I can do a couple things here.
Or subtract 2x. Oh no,
No,
subtract 1.
not yet, because we don't have it. We don't have it in the form of a quadratic yet.
You could add 1.
Okay, that's what I was looking for. In other words, this equation becomes y equal 2x plus 1. Now I can set this equal to that. So I have minus 3x squared equals 2x plus 1. And now how do I get it into the quadratic that I can factor?
Sorry, what did you say?
So now what do I do to get it into the quadratic that I can factor?
Add 3.
Add 3x squared to both sides.
Okay.
In other words, if I add 3x squared to that side, I will be left with 0. Now I've got 0 equals, and I'm going to put it in order. And it doesn't matter if it's on the right or left. I'm going to do the same thing. Help me factor this.
X plus plus.
Well, let's first of all get our first terms correct. Let's get this term and let's get this term.
X and X.
Well, would x times x multiplied together give you 3x squared?
Oh, X.
X and 3x would.
Yeah.
Okay. Now, what's my signs?
Plus plus.
Okay. But notice that this doesn't work. In other words, this does not factor nicely, because this gives me a middle term of 4x squared, not 2x. I meant 4x and not 2x. So this doesn't factor, because the only factors of 1 are 1. So how else can I solve this? If you have a quadratic that can't be solved by factoring, how can you always solve it? I'm guessing you must have had this, otherwise they wouldn't be giving you this question. This is the quadratic formula. Okay? This is A, the coefficient of the x squared term. This is B, the coefficient of the x term. And this is C, the constant. So let's solve this using the quadratic formula. So what's minus B going to be?
Hold on.
What is B?
-2.
No, look up here. Well, B is 2. So negative B is -2. I'm sorry. Plus or minus the square root. What's the rest of it?
Of 2 squared minus 4 times 3 times 1 over 2 times 3.
Very good. All right. The part that's inside the radical is called the discriminant. And it has its own name for a reason, in that if we're trying to solve a quadratic formula like this problem, sometimes it's useful to look at what's inside the radical and notice that that's a negative number, because we have 2 squared, which is 4, minus 12. So I'm going to have minus 8 inside there. Have you had imaginary numbers yet?
No.
Surprised you're getting this problem, because at this point you've been taught that you cannot take the square root of a negative number, correct?
Correct. So this would be no solution.
Okay, that's fine. We can call it that. It actually has 2 imaginary solutions, or they're called complex solutions. But that requires imaginary numbers, and if you haven't had imaginary numbers yet, then the only answer you can give to this problem is no solution. All right.
Okay.
So number 4, now they're mixing it up a lot on us. It's the first thing I want to do here.
Add x to the
I can do
multiplication.
Yeah, I can do that, and then I can equate the right side to the other right side. But notice something else I can do. Since this is asked us to do it by substitution, I'm going to do this by substitution. In other words, I'm going to take y equal x plus 3 from the second equation, and I'm going to substitute x plus 3 wherever I find y in the first equation. So I'm going to go in the first equation, and in place of this y, I'm going to write x plus 3, and then minus x equals 2x squared minus 5. This is really a different kind of substitution, but usually what people mean when they say substitution is this. Okay, now if I solve this, notice that that x goes away. I've got a 3 over here. Let's take the 3 on the other side. So I'm left with 0 equals 2x squared minus 8. Now, to solve this, there's no x term. So I can solve it like we solved the first set of problems we were doing tonight, by taking the square root. Let's do it that way. Remember the first page of problems? How would we have solved this? Let me write it like this. What's the first step?
Add 8.
What's the second step?
Divided by 2.
And the third step?
Find the square root.
So what's the answer?
X equals 2. Plus or minus 2.
I'll get you to say that yet. Okay, let's go to number 5. Here they want us to solve it by elimination. Elimination is exactly what it says. Now let's talk about something else first. If I have an equation a plus b equals c, and another equation x plus y equals z, I can add these two equations. It's always correct to add equations so that I get a plus b plus x plus y equals c plus z. I can also subtract these two equations. A plus b minus x plus y equals c minus z. So no matter what equations we have, it's allowed to add them or subtract them. So keep that in mind to solve by elimination, because that's the way we solve problems by elimination, is by adding or subtracting. Now this first one they've made real easy for us. Notice that I can add these two equations, and what will disappear? Let's go back a step. If I'm going to solve two equations by elimination, you usually want to get it in the form of x plus y equals some constant to begin with. So before we're going to try to solve these two equations, notice that I could solve them by substitution real easily. I would set this equal to this and just proceed. But since they asked us to solve it by elimination, we've got to do it in a slightly different manner. We want to get it first into this format here, where we get the x and the y on the same side and the number on the other. So what do I have to do to this first equation to do that?
Make them equal to each other?
Well, I'm going to get all the variables on one side. So I'm going to add 2x. So I'm going to have y plus 2x equal 4. Notice that that's in that format right there. Now, the second equation, I want to do the same thing, only to get both variables, or all the variables on the left side, I've got to add both of these. So the second equation becomes y plus, let me write it this way, it becomes x squared plus y minus 2x, because I'm bringing this 2x over to the other side, equals 0. Now, when I add those two equations, all right, let me back up. I can't believe they gave you this problem as your first problem for solving by elimination. When you're solving a system of two equations by elimination, you have two variables, x and y. So our object is to eliminate one of those variables. Well, notice that I could add these two equations and I would get rid of the 2x, but I would still have a y, I would have two of them, and I would still have an x squared. So I don't want to get rid of the x variable, I want to get rid of the y variable. If I get rid of the y variable, now I will have an equation strictly in x. So let me write this equation right below. Didn't change anything. Now taking these two equations that I have, that are exactly the same as these two here, subtract the bottom one from the top one and y will be eliminated. And we will have a quadratic in x that we can solve. So I'm going to take this top equation and I'm going to subtract the bottom equation. Okay, so x squared minus 0 is x squared. Y minus y is 0. Minus 2x minus this 2x is minus 4x. And 0 minus a 4 is minus 4. So now we have x squared minus 4x equals minus 4. How do I solve this? Did we do this one already? No.
I'm not sure.
No, we didn't do it. That's okay. How do I solve this one? How do you solve quadratics that have an x squared term, have an x term, and have a constant?
The square root?
No, you can't use that method because we have an x term. But I can put everything on one side and factor. So I can add 4 to both sides. So now I got x squared minus 4x plus 4 equals 0. This is the standard form we want a quadratic to be in to solve it. The reason I ask had we done this one is because we did have another one that factored exactly like this. What does this factor into?
Negative. Oh, yeah, we did have one like this. It was x minus 2 and x minus 2.
Yeah. So x equal 2 is the solution, and we got it by elimination. All right, let's do another elimination because I kind of didn't give you very good instructions on that. Remember that to solve by elimination, we want the thing in this kind of format. So what do I have to do to this first equation to get it in that format?
Hold on, the house phone's ringing.
Okay.
Can I answer it?
Marina?
Can you hear me?
Yes.
Okay, I just
Okay.
woke up, sorry.
This is a little unusual because usually when you solve equations by elimination, they give it to you in this format. This is the first time I've ever seen anybody be asked to solve by elimination, and they don't give it to you in the format that you would use. So it forces us to put it into that format. So how do I take this equation and put it into this format? And this format also includes any squares. In other words, it would also be like that. The format is that all of the variables are on the left side, nothing but numbers on the right side. So convert this equation for me.
Wait, what side do all they have to be on?
Up top here. All of the variables have to be on the left. All the numbers have to be on the right.
Okay, so plus x squared
Keep going.
Plus 5x
Minus
equals
5x
yeah, minus 5x.
equals 8. Okay? So we got that first equation in the form we need it in to be able to do elimination. Now let's get the second equation in that same form. So the second equation is, here, let me erase the first one. So the second equation is y equals minus 2x plus 2. So transform this into this format.
What do you mean?
I mean, put all the variables on the left side and leave the constant on the right.
So do you divide by negative 5?
No, we're working with this equation, the second equation. We have to get it into the format of up here. In other words, take this second equation and modify it so that both variables are on the left and the numbers on the right. What do you got? Add 2x to both sides. What do you get on the left?
Oh, you mean,
In other words, I'm taking this and turning it into this.
so negative 2x plus...
No. Move the 2x to the left. The y is already on the left.
Oh, we're only doing the top equation?
We're doing this one that I've underlined right here.
Oh,
We already did the top one. That's how we got this one. So this is equation number 1. Now we need equation number 2. But we need it in the right format. So I'm going to add 2x to both sides. 2 is still over on the right. Okay? You with me?
Yeah.
Okay. Now I'm going to eliminate a variable. What do I have to do to these two equations to eliminate a variable? At this point, I'm only dealing with these two equations right here. And I want to eliminate a variable. What can I do to these two equations in order to eliminate one of the variables, either x or y? Play piano.
Sorry, what'd you say?
What do I have to do to these two equations to eliminate a variable? I need to subtract number 2 from number 1. Notice that if I take equation number 1 and if I subtract equation number 2, what that means is I subtract the left side from this left side and I subtract the right side from this right side. Remember, you can always do that. If A equals B and C equals D, then A minus C equals B minus D. You can always subtract two equations from one another. The reason I want to do it is because y will disappear. What's y minus y? 0. Now what's minus x squared? Minus 0x squared. Notice that there's kind of a dummy variable here that's implied. What's minus x squared minus 0? What's the answer to this? minus x squared. The 0 disappears and you're left with whatever you started with. So I got a minus x squared there. Now what's minus 5x minus a positive 2x? Subtract those two.
Subtract which two?
The two that are lined up. The minus 5x minus the 2x. What's the answer to that?
Negative 3x.
No. Remember, when you have subtraction problems, turn them into addition problems. The reason this confuses you, Marina, is that this minus sign does not mean the same thing that that minus sign does. This minus sign means subtraction. This minus sign means negative 5. Okay? So to do these problems, make them simple by turning them into addition problems. And we do that by finding the subtraction sign, turning it into an addition sign, and then making the next term the opposite. Now what's minus 5x plus a minus 2x?
Sorry, hold on a sec. Dakota Ridge called and said that tomorrow ACT tests are at 8 a.m. and you cannot be late, and all Dakota Ridge juniors needed. Okay. No, this is when you guys were gone. Oh, okay. Yeah. Okay. Okay, what'd you say?
So what's a minus 5x plus a minus 2x? What's minus 5 plus a minus 2?
Oh, negative 7.
So this answer down here is minus 7x. And then what's 8 minus 2? Eight minus 2?
6.
Okay. So now we have the familiar quadratic that we've been looking at all day. How do we solve this?
X. Oh, by factoring?
Well, you're right. We're going to factor it, but we got to get everything on the same side, and we would prefer the x squared term not to have a negative sign in front of it.
Oh, add 7x.
Well, I'm going to move this to the right side, and I'm going to move that to the right side. So what I'm going to be left with is 0 equals x squared. That's what happens when I move this to the right side. Plus 7x. That's what happens when I move that to the right side. And I've got a 6 over there already. Now we have it in shape to factor. Notice that my coefficient is positive. That's what I want. You don't want to try to factor these starting with a negative coefficient in front of the x term. So help me factor this.
X and X, and then plus plus.
Now tell me what I want. I want what? Factors of
6 that add to 7.
Right, because of this. That's why I want them to add to 7. If that was a negative sign, I'd want factors of 6 that subtract to the number 7. So what are my two factors? What are factors of 6 that add to 7?
It'd be x plus 6 and x plus 1.
Okay, so what are my two solutions?
Negative 6 and negative 1.
Okay, good. All right. Now, number 7, notice that they have given us the first equation in the form we want it. I don't have to do anything with it. It's fine. I've got both variables on the left, and I got the number on the right. Second equation, not so. So let's manipulate the second equation to put both variables on the left and the number on the right. So how's it going to read? If I start with this, how do I change that equation to get both variables on the left side?
What do you mean?
Well, what are the two variables? X and Y. So if I want to get anything with an X or anything with a Y in it on the left side, I got to move this to the left side and I got to move this to the left side. So what does that leave me with? What do I have after I do that? Y plus 2x squared minus 9x equals 0. Now, if you don't understand exactly what I did, say something.
I don't understand what you did.
You don't?
No.
I added 2x squared to both sides, and then I subtracted 9x from both sides.
Oh, so we're not working on the first equation?
No, we're working on the second equation. This is equation number 2, right here. The first equation is this one here. I'm trying to write the second equation in the format that I need it in so that I can solve this by elimination.
Okay.
And that's what I did. In other words, I rewrote the second equation this way, right here. Now I can solve it by elimination by subtracting equation number 2 from equation number 1. When I do that, y disappears. It gets eliminated. And I'm left with just an equation in x, which I can then solve. When I subtract equation 2 from equation 1, y minus y is 0. 0 minus 2x squared is minus 2x squared. 6x minus a minus 9x is plus 15x. 7 minus 0 is 7. So now I have another quadratic that I need to solve by getting it all on the same side and factor. And unfortunately, I'm going to have to run. I have a 5:30 online appointment, and it's 5:31 here.
Okay, well, thank you.
Okay, Marina. I'll talk to you next time.
Okay, thanks.
Bye-bye.